Hello viewers, welcome back to my channel. If you are a new viewer, I recommend you to go back and watch part 1 of this series. On 3rd September 2023, Aditya-L1 had a majestic liftoff from Sriharikota. After its separation from the rocket, Aditya-L1 will perform a series of maneuvers around the Earth. The destination of Aditya-L1 satellite is to reach L1 point, which is nothing but Lagrange point 1 between Sun and Earth. Let's get some insights about these Lagrange points. Lagrange points, also known as liberation points, are five specific positions in space where the gravitational forces of two large objects such as Earth and Moon produce enhanced regions of attraction and repulsion. These points are valuable in space exploration and satellite deployment because they allow spacecraft to remain relatively stationary with respect to the Earth or the Sun, reducing the need for frequent orbital adjustments and thus saving a lot of fuel. Lagrange point L1. This point lies along the line connecting the two large objects and is located on the side of smaller objects. So say if we are talking about Sun and Earth, it will be much closer to Earth because it is the smaller object. At this point, the gravitational forces of the two objects balance out in such a way that an object placed there will stay in a stable position relative to both. Lagrange point 2, which is also known as L2, is also on the line connecting the two larger objects, but it is located on the opposite side of the smaller objects. So if you are taking an example of Earth and Sun, it will actually be in the backside of the Earth. Here also all the objects will maintain a relatively stable position which is relative to both Earth and Sun. Here we can say take an example of JWST, which is James Webb Space Telescopes. Lagrange point 3 or L3. This is located on the line connecting the two larger objects, but on the opposite side of the system from L1. Let's say if we are taking the example of same Earth and Sun, it will be on the backside of Sun. So this is generally unstable. This point, if you see, it's generally unstable and not commonly used for space missions. Lagrange point 4, also known as L4. L4 is one of the 2 points that form an equilateral triangle with the two large objects. It is 60 degrees ahead of the smaller objects in its orbit. Here also the objects can remain stable in position. We can see a lot of asteroids or satellite constellations over here. L5. Same like L4, L5 is also at an equilateral triangle point, but it is just 60 degrees behind the smaller object. Objects at L5 also can maintain a stable position. Here also we can see so many asteroids and other satellite constellations. An orbital maneuver in spaceflight, often referred to as burn, involves using propulsion systems to alter a spacecraft's orbit. When dealing with a spacecraft that are far from Earth and in orbits around the Sun, such a maneuver is termed as Deep Space Maneuver or DSM. These maneuvers are essential to raise the spacecraft's orbit and increase its velocity, allowing it to reach its intended destination, particularly in interplanetary missions like Chandrayaan, Mangalyaan, or Aditya-L1. So now the question is how to gain this additional velocity. Any guess, guys? Okay, I will explain. This can be supplied either directly by the launch vehicle or through successive firing of spacecraft's propulsion system. So out of these two options, Aditya L1 mission has chosen the maneuver path. There are two reasons behind this. The first reason being the limitation of PSLV. As we all know, PSLV is a proven cost-effective launcher, but it is not possible to place Aditya L1 spacecraft of about 1475 kg beyond an orbit which is 235 into 19,500 km around the Earth. So to achieve an orbit which will go to the Sun Earth L1 point, which is about 1.5 million kilometers from the Earth, The spacecraft need to do some earthbound maneuvers by its propulsion system. The second reason being the cost effectiveness of the whole mission. ISRO's Aditya-L1 mission cost is estimated to be around 4,000 crores, which is very less compared to even a Hollywood movie. Now let's have a quick look at the various earthbound maneuvers performed by Aditya-L1. After its launch on September 2, 2023, the first earthbound maneuver to EB and ASH-1 was performed from its track and a new orbit of around 245 km into 22,459 km was achieved. The second earthbound maneuver was performed on September 5, 2023 and a new orbit of 282 km into 40,225 km was achieved. The third earthbound maneuver was performed successfully on September 10th and a new orbit of around 296 km and 71,767 km was achieved. The fourth earthbound maneuver was performed on September 15, 2023 and a new orbit of 256 km into 121,973 km was achieved. The ultimate objective of all the maneuvers which we see is to put the spacecraft into a halo orbit around Earth's Sun Lagrange point L1, which is around 1.5 million km from Earth. ISRO is all prepared to send off the satellite from Earth, putting the spacecraft on its way to halo orbit around the first L1 point, which is between Sun and Earth. As we already discussed, this is a space region in space between the Earth and the Sun, where the gravitational influence of both the bodies balance each other out, allowing a spacecraft to maintain its position with a minimal expenditure of fuel. The location also allows Aditya-L1 to continuously monitor the Sun without having to worry about the eclipses or occultations. Also, at L1, the spacecraft would remain quite stable with minimum propulsion energy requirements for corrections in its orbit, such that one side of Aditya will always face the Sun and the collected data can be transmitted to the Earth from the Earth facing side. VELC, Visible Emission Line Coronagraph, which is the primary payload of Aditya-L1, is intended to send about 1440 images per day to the ground station for analysis after reaching its intended orbits. The final burn is expected to take place at around 2 a.m. IST on September 19, 2023, after which the Aditya L1 will commence its journey. It's a big journey, three and a half months journey to the sun, Lagrange point. So that's it, guys, for the time being. If there is any mistake, please point out in the comment section. If you like this, please subscribe, share, and enjoy. Thanks all for the watching and patience. Signing off.